Welcome to Easy Learn. This is Introduction to Electronics Season 3 Episode 2 English. As you know, I will give the introduction about the terms very precisely as in Episode 1, and today is the Episode 2. So let's start the topics what we are going to discuss today. And the first topic is the resistors. Second is series combination of resistors and parallel combination of resistor and type of resistors. These are the topics we will discuss today, and let's start the first topic. The resistor is a passive two-terminal electrical. There is the main thing is the passive. Here is in this definition there are two types of the components. One is active components in the terminology of the circuits analysis. One term is called active components, second term is called passive components. The active components are those who energize the circuits, for example like battery, while the passive components are those which absorbs the energy, like resistance, which takes the energy, or it basically absorbs the energy. When required, we use this resistance. A two-terminal you can see in diagram, and there are the colors on it, and these colors are used for finding the its value, and this is the symbol used in the when we are using in the circuits, and this is the Ohm symbol. Okay, this is the basically an example view, and when we are discussing about example, the where my cursor, we can assume this as a resistance, this person, and this pushing person is like a voltage. If there is no resistance, you can see that this person will be there in a second, but due to this resistance there is a barrier, and resistance acts like that. This is just for understanding. Okay, next slide. Here is a resistance, and resistance example. For example, you can see that the voltage is pushing the current, and there are the resistance, and there is a resistance, and you can think like this is a hollow path, and the resistance is just pushing the pipe, like it's like the path for the current is narrow. If we increase the resistance, like here, this and this terminal, so if the path is a little bit limited, and then then limited current will flow, and that is the purpose of resistance. This is just for understanding. Okay, the terms involved in the resistors are: number one, Ohm's Law. And if we discuss about the Ohm's Law, first let me tell you that there are two types of the resistors. Number one, ohmic resistors, or we can call this as linear resistors. Number two, non-ohmic resistor, or we can call it non-ohmic devices, non-ohmic or non-linear resistors. First category is ohmic or linear resistor. These are those type of resistors with whose resistance changes directly or linearly without any variation in the graph. I will show you in the next slide as well. While first, the thing here I want to tell you, the first term, Ohm's Law. Ohm's Law is used to calculate the voltage and current. This is V is equals to IR. Ohm's Law states that voltage is equals to current multiplied by the resistance in the circuit, but the main thing here is it is only applied to ohmic or linear resistors, because when we move towards the non-ohmic, more complex calculations involved, and definitely if more complex calculations, then when involved the temperature, this is basically a practical case, or you can say that this is a theoretical work. If we move towards the practical work, graph will be like this one. This is the graph of practical case, while you can just imagine that this is like theoretically or ideal cases, because in most cases the graph is not like exactly the linear as like this. This is the ohmic or linear, and this is non-ohmic, as I was discussing in the last slide. So you can see that if we calculate it by using the formula at this stage, for example, let's say this is 1 and here it is 0.5, half of this. If we can say that at 0.5 volts, the current in this graph is also 0.5 milliampere. So it continues in this pattern. So by using this, by calculating at one step, we are able to calculate at any step, because we know that this graph is going linearly. For example, by using this technique, that I know that at 0.1 the value of the current is 0.5. I can go here at 0.6 it is half, as at 0.1 it is half, 0.5 the value of current, so at 0.6 it's also half 3. So we can continue this, but in the practical cases we cannot continue this step, this assumption, because the graph is changing at each stage, irrelevant. For example, if the resistance if we consider about the temperature changes, then if the temperature increase, the resistance will also, for example, decrease. If the temperature decrease, then resistance increase. For I am discussing about thermistor later, I will also show you. Okay, let's discuss about electrical energy. This is basically the same thing in the above and in the below. I write in PPT, but it's not looking good, so I made a screenshot and write in the book format, PDF. Okay, this is basically energy. Total energy is equals to total charge multiplied by the total voltage, and I can also replace the charge with the IT. As you know, this is generally the formula is current is equals to charge per unit time. I is equals to Q over T. So I derive this is equals Q is equals to IT. So this is just I put the value of Q here. Q is equals to IT. In the next step, I made put the value of V is equals to IR by Ohm's law here. If I put the V at replace the V by IR, then it becomes I square RT. And if I put the value of I here again from Ohm's law, I is equals to V over R, then the formula becomes, these are the same things, and this term is equals to this term is equal to this term. Just these terms comes from each other by substituting the different values of different terms. So the basic thing here to remember is energy is equals to power multiplied by time. As you know, this is the energy is equals to power. This term comes from here, like power is equals to IV or VI. This is power here, this is VI is power, and T comes from this time. We can say VI replaced with power. This is power. Okay, next slide. Power is equals to voltage multiplied by current. The same thing I already told you. If you here I put the power is equals to V is equals to IR, and power can also be written right as I square R. In the next slide I write it here like substitute the value of I as in the previous I put the value of V. So here I put the value of I is equals to V divided by R, and it becomes V square over R. There are two different terms I can use. Energy is equals to power multiplied by time, and power is equals to energy divided by time. The time goes to the other side of the equation, and definitely in reciprocal. When resistors were connected in, this is the second term, series resistance. Number one is the series resistance, and number two is the parallel resistance. If I discuss first the series resistance, the combination is like this as shown in the diagram here. First resistance, then second, first output of the first resistance is the input of the second resistance, and the output of the second resistance is the input of the third resistance, and the output of the third would be the input of definitely the fourth. if I connect in this pattern, then definitely I can call this as the series combination. And you can also note it if in series combination, if one connection is disconnected or turned off, then the whole path is disconnected. The energy is conserved. The main thing here is energy is conserved if I calculate ideally at each step, and then by using that formula I calculate the total value of voltage or energy. In simple terms, we can say the energy is conserved and the total energy would be same. Okay, there are different formula for series and the reverse formula for the current. So first for parallel combination. So first discuss about the series. In series, the total resistance is added up. For example, in the last slide I show you R1 plus R2 plus R3 plus 4. Total resistance is the addition of all the resistance, while this we can also write it as total, R total, or we can also write it R series. R series I write it because this is the series resistance. Okay, for voltage, the voltage is also V1, voltage across R1, voltage across R2, voltages across R3. Here in this example you can also see, for example, this is R1, for example this is R2. So voltage across this one and voltage across this one is the total voltage, for example 10 volt. We can calculate by using the Ohm's law this, but I did not calculate it right here. You can calculate. Current remains the same. As you can see, this blue line is same at any stage. You can easily see that 0.5 milliampere is the same throughout the circuit. So we can, in the series combination of resistors, the current remains the same. This is very important thing, because when we move in the parallel combination of the resistors, this concept would be the reverse of this. So if you can remember the for example series resistance, you can learn or you can remember, then the parallel would be in contrary to the series resistance. So remember one thing more carefully, that this current remains the same in series resistance, while if we move in the parallel, the voltage remains the same, as I will show you in the next slide. Okay, here is a simple example of the R equivalent resistance. For example, there are the two resistance. So how we calculate the total resistance in the series? As you can see, these are connected in series. So 100 ohm plus 300 ohm, the equivalent resistance in series is the addition of the resistance. So total resistance is 400 ohm. I did not calculate the other parameters of total voltage or total current, because my concern is series resistance. So I'm just calculate the resistance. Okay, next. Here is while in the parallel, we are in now, the next topic is parallel resistance. In parallel combination, the total resistance is 1 divided by R1. Reciprocals, the main thing is this is reciprocal. This is totally the reverse, or you can process of the previous slides. Series resistance is totally the anti-parallel of the parallel resistance. I'm just kidding. Okay, coming back towards the topic, the total resistance is the reciprocal of the sum of the reciprocals. As you can see, 1 over RT, the total resistance here is equals to 1 over R1 plus 1 divided by R2 reciprocal. So reciprocal of R1, reciprocal of R2, reciprocal of R3 is equals to the reciprocal of the total resistance. If we want to calculate the total resistance, not reciprocal of total resistance, but we want to calculate the total resistance or parallel, then what it becomes 1 divided, or we can write it as 1 divided by 1 over R1 plus 1 over R2 plus 1 over R3 for the total for the R parallel total resistance. Or we can also write, when this term goes to the above in numerator, then the power will be -1. So here is the important thing is voltage remains the same, as I was telling you in the previous slides, while the current is added up. Here is an example of this one, that different resistors are connected in the parallel, combination. If this resistor would be eliminated or disconnected, I will disconnect, for example, this resistor R1, then the circuit will continue without any effect of R1 or if I, for example, if it in series, then if I disconnect any of this resistor, then the whole circuit will be disturbed and the current will be stopped. While here is the alternative paths, and this is called the parallel combination. And while this is here, in this case there are resistors, we can say that this is the parallel combination of resistors. Here is an example. Once again, the equivalent resistor is calculated 1 divided by R, reciprocal of R1, R2, R3 and so on. You can also see that the values of R1 here, in this case, for example, 20 ohm, 30 ohm and 30 ohm. So 1 divided by 20 ohm, 1 divided by 30 and 1 divided by 30, if we add it up and divide by 1, so the answer is 8.57 ohm. Here comes some important symbols used in the circuits. If the two wires crossed and not joined, the circuit is like this. If you are, it's not clear, then I can draw. For example, this is the first wire, and if in circuit I'm one wire is crossing this wire but it's not joined, then I will little bit a curve is used that shows that this wire is not joined with the first wire. So if I draw like this, it means this dot means that this wire is joined with the first wire or any other wire. This symbol of resistance is used. This is old symbol. Nowadays this symbol is used, which is at the bottom. The upper symbol is used early in the early books, some old books, while this symbol is the new symbol and replace this, because you can see that fixed resistor also has this symbol while the variable resistor also has the same symbol. So for this we basically use this symbol for resistance, and for variable we can use this one. All other symbols are also important, but I am just concerning with the resistance, so I just discuss some symbols, and you can also see other symbols. I will provide you this presentation that I made in the description link. You can easily watch other symbols, okay, learn other symbols as well. Okay, types of the resistors, last topic. There are different types of resistor. For example, if I want to use thermistor, as many people also know thermistor as a temperature sensor, but basically how it senses the temperature is by the resistance of the environment, or by basically the variation of the resistance is the main thing behind these sensors. Mostly sensors are based on the resistors. So there are two types of resistors. One is called fixed resistors, and the second type is called variable resistors. Depend upon the circuit which resistor I am selecting, it's upon me, my type of the circuit. For these are the some fixed resistors, as you can see, and this is the new symbol, old symbol I already described. And the resistor values there are different values of the resistance commercially available. For example, I write the significant figures right here. You can see that, for example, 10, 11, 12, 13, 15, so on. These are just significant figures I write for simplicity. Other figures are also available, but I want to tell you right here, if times if you don't have, for example, you need a 12 ohm resistance and you have just 10 ohm or 15 ohm in the market, you can make this resistance by, in the previous slide I forget to explain that here. This point. All other values can be obtained by combining the resistor in series or parallel as appropriate. Okay, this point means that if you, for example, I want to make a 12 ohm resistance or 12.1, I can make this resistance by using series and combination, parallel combination of the resistance, and all of any other appropriate value I can make. Okay, next moving, this is that 47. I explained that 47, 51, 56. For example, 47, it means that this is not only 47. I just write for simplicity 47. It means 4 and 7, 4.7. If the point dot moves the next, then it becomes 47. If dot moves one step further, then it becomes 470, also available. This is a series basically, 4.7k, 47k, 470k, and 4.7 mega ohm. This is basically a series. I want to tell you that each and every figure I write it here is basically a complete series behind this. So you can also learn about the series later on. Because this is introduction, I want to make it short. Okay, resistor tolerance. Tolerance is basically the variation in the value. If, for example, if at I bought a resistance, I had a resistance of 10,000 ohm or kilo ohm, 10,000 kilo ohm. If its resistance is 10% tolerance, then it means it has a variation of 10% downward or upward. There may be a variation of 10%. The manufacturer basically provide and tell us that how much variate it can be from the actual value. It may be also sometimes depend upon our certain conditions, temperature and load as well, and different type of conditions also. And but the manufacturer also provide us that there are certain variations is called tolerance in the term of the resistors. So it provide the lesser. Okay, previous slide please. Okay, if there is a 10% tolerance, it means it's not much good. For example, if 1% tolerance, it means it's much accurate. It's just 1% fluctuations are available. So I always prefer the less tolerance percentage. There are two type of methods, color coding and here this is a color coding method. You can see the colorful bands on the resistors, while the new resistor also come which has directly the resistor value written on the surface, on their surface, and also have occupy less space. But these resistors also have still used in some boards, and its value can be measured by using color coding method, while this resistance is directly written on their surface, while we can calculate its resistance by color coding method. Next slide. Yes, this is the tolerance. I already explained that tolerance is by it's a color code method resistance. If the last band is used for the previous slide. Yes, here you can see that my cursor, that here is a band in this figure. There is a golden band. Last band is golden, so the tolerance is here. Where is gold? Yes, it's a gold, and it means it's a 5% tolerance in this. For example, this resistance is 10,000 ohm, 10%, then it has a 5% fluctuation plus minus. If it was brown, then there is a different tolerance value, and for red and silver as well. And this is the types of the resistance. Further continued topic, and this is the method how we can calculate the color coding method, the value of the resistance. The first band is used by using this table. You should remember, everybody should remember this table, and black, brown, red, orange, yellow, green, blue, violet, gray and white. There are different value from 0 to 9, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and same. If this first band, for example, let's take an example. If my first band is brown, then I will move here is a brown, and I check the value, it's a 1, so I write it here like 1. Then I will check that my second band. If my second band, for example, in this case is a black, then I move in the table, and black is on the top of the table, so black has a value once again 0, so 0 value, so I write it here 0. For the first two bands I write their value. For the third band, remember, I multiplied their value with the previous value. For example, this is 10 already made an I had write from the first two bands value is 10, and the third, let's check, third is, in my case it's red, so third, where is red, this is red, so it's 100 multiplied by its value here is 100, so I can write multiplied. I'm not good in using this PPT files, and this mouse is I don't like this mouse basically of mouse of computer, because I'm not good in writing here. Please understand, this is 100. Maybe it's not look like 100, but it's 100, and 100 is multiplied by 10, then it's definitely 1000, and this is the value that I want to tell you. Okay, these values are very easy to learn. This gradually increase one by one zeros, and in a sequence, for example 1, then 10, multiplied by 10, 100, multiplied by 10, multiplied. This is a figure used in the multiple figures, and you have to learn. And most important that if in this case, yes, you can see that there's first band brown, second band is black, and third band is red, while there is no fourth band. If there is no fourth band, it means the tolerance of the resistor is very poor, and it's almost 20%. So the 20% tolerance, if there is silver, then different value I already explained, and there are some further example for practice. Variable resistors I already explained. Variable resistors are used for if we need a different value. For example, at some stage I need another value, at the next step I need another value, so I use a variable resistor instead of replacing again and again in circuits. There are different types of resistors available. For example, this is an old type, and large occupy large space. As you can see that this size is large, and you can use nowadays it's found in mostly laboratories. Rheostat, its name is rheostat, and this is used for this is a sliding contact. Basically it move here in this direction as well, here in this back and forth, so its resistance is varied. These are the two terminals used for the connections as well. Okay, there are different types of the resistor. Variation is usually obtained by sliding the contacts like this one, and there are different screw is also available, like in this case mostly cases these are the screw. This is also very familiar. You may be familiar with this one because this is mostly available in the previous or old CD rooms, etc., or most importantly in the amplifiers. This is mostly used in amplifier or dimmers of fans as well. Okay, next, this is again the same thing, light dependent resistors. This is the thing that I was explaining at the start of the lecture, that light dependent resistors, basically they are mostly called the sensors, light sensors. When the light basically falls on the light dependent resistors, here its electrical resistance changes, usually decrease, its resistance is decreased. This is the graph. When the light increase, its resistance decrease. As you can see that resistance is first in the first part of the light. When the light falls in the first here in you can see the graph is gradually decreasing, while when it's more steep, while if light is intensity is increasing continuously, this graph is changed, will almost linear. This type of graph, as explained, I already explained that this type of graphs are called non-ohmic devices. So this is a non-ohmic. So non-ohmic devices are those which whose resistance depends upon the temperatures, intensity, as well as other factors, pressure, etc. So these type are non-ohmic or non-linear graph and non-linear devices. So we cannot apply the Ohm's law. These are practical cases. Ohm's law is just for theoretical. So This is a temperature dependent resistor, same case called temperature sensors as well. Their resistor also changes with the their resistance is changed like if temperature is increased, resistance is decreased, and there are different types. For example, this one here you can see that rod, disc, beam, and their symbols as well, different things. By the way, this is an also high temperature NTC sensor. Okay, it's time to terminate this session of the lecture, and the topic discussed in the next episodes are the resistor as voltage divider. This is important topic, so I will discuss all the relevant examples regarding this, and I will also give you some problems for your practice, and at the end, if time available, I will also discuss the non-linear resistors. Okay, it's time to say that if you like this, then share this to spread the knowledge in the easiest way. Watch, learn, grow, and see you next time.